Okay, in this video, what I want to do is show you how to determine a quadratic function from 3 points on the graph. So, first of all, quadratic means degree 2, right? A quadratic function is degree 2, meaning it's x squared plus some other lower terms. And the graph of a quadratic function is a parabola. It's a curve. Okay, it can look like this opening up, or it could look like this opening down as a quadratic function. So that's what quadratic means. Now, I just want to remind you, you should have a background in algebra already if you're watching this video wanting to learn about this. But if you want to, you could determine a linear equation, a linear function, using just 2 points. Okay, so a linear function means the degree is 1. Degree is 1, and the graph of a linear function is a line. So you can imagine if you have 2 points, you can easily determine the line, and then the function, since it's degree 1, meaning it just has x, no x squareds, no x cubes, etc., might be something like f of x equals some coefficient a times x to the first plus a constant b. Alright, so in order to get this function, all you need is 2 points for a linear, okay, to get this function. With a quadratic function, to get the curve that is the parabola, you need 3 points to get the quadratic function. And a quadratic function in general looks like this. F of x equals, your first term is going to be a x squared term, so ax squared. And then you have your lower degree terms. So then you've got your bx, that's your degree 1 term, then you've got your constant c. So a, b, and c are constants. Of course, a can't be 0. A cannot equal 0, because if it did, you would have no x squared term and you'd have a linear function, okay? But they can be negative, they can be fractions, they can be decimals, the constants a, b, and c. Alright, so what we're going to do is look at how do you determine this type of equation from 3 points on the graph. It's not as straightforward as a linear function. You should probably have done that before. So let's talk about this. So let's do an example. Determine a quadratic function that passes through the points, let's say 0, 11, 3, 11, and 5, 31. Okay, so let's say that is, we want to determine the function that passes through those 3 points. So just to get a feel for this, just to understand what this looks like, you could graph it. And so 0, 11 might be like right here. 3, 11 might be here, let's say. And 5, 31 might be way up here. So maybe we're talking about a quadratic function, a parabola that looks something like this. Okay? So what is the function for this? In other words, what are a, b, and c? Well, now we have 3 unknowns here. So when you have 3 unknowns, one way you can try to determine them is to use a system of 3 equations. And so that's precisely what we're going to do. We're going to take each ordered pair up here and use the fact that they are on the graph to create 3 equations. Alright, so let's take our function again. This is the equation we're going to use. F of x equals ax squared plus bx plus c. That's the generic equation we're going to use, but we're going to create three different equations by using the ordered pairs. Okay, so the ordered pair 0, 11 means that when x is 0, y is 11. So in this particular equation, this f of x is y. So what I'm going to do is replace x's and y's with 0 and 11. So I get this equation from this ordered pair. Y is 11, so f of x, y is 11, equals a times x squared, x is 0, plus b times x is still 0, plus c. And so if we simplify this equation down, we get the equation c equals 11. So there's one equation. All right. Let's use our next ordered pair, 3, 11, and do the exact same thing, plugging into our function equation. So y is 11, f of x is y, remember, equals a times x squared, x is 3, so 3 squared or 9, plus b times x is 3, plus c. Simplifying this equation, we get 9a plus 3b plus c equals 11. And so we're going to kind of try to do this, keep a, b, c, and then equals a constant on the right side, okay, if we can do that. Alright, so there are two equations. Now we need a third equation from the ordered pair 5, 31. Plugging in 31 for y, I get 31 equals a times x squared, x is 5, so that's a times 25, plus b times x is 5, plus c. And we get our third equation, 25a plus 5b plus c equals 31. So here is our system of three equations. So I'm going to write this as a system. The unknowns are a, b, and c. Okay, so we're trying to solve for a, b, and c using this system of three equations. So let's write our system here. And we'll be strategic. I'm going to have c equals 11 be our last equation. And I like to have, for our first equation, the simplest one. So the simplest one to me looks like the second. So 9a plus 3b plus c equals 11. You don't have to do it this way. It depends on what experience you have solving systems. You could do this using matrices if you know that. I'm gonna solve the system using just basic elimination. Okay. So our second equation is 25a plus 5b plus c equals 31. So now we have our system. We need to solve for a, for b, and for c. Okay. So our goal now in solving this system, the way I'm going to do it using elimination, is this last equation is already done. I don't need to do anything. The second equation, I need to eliminate this. I need to eliminate a from my second equation. And I'm going to do that using my first equation, my first row. So what I'd like to have happen is I'd like my 9 and my 25 to be able to add up to be 0. So I know that I can turn 9 into 225 and I can turn 25 into 225 through multiplication. So I'm going to take and I'm going to multiply, let's say row 1, I'm going to multiply row 1 by negative 25. Because if I do that, negative 25 times 9 is negative 225. And then I'm going to multiply row 2 by 9, because that's going to make that positive 225, which will add to my negative 225 to get 0, which is what I want to do. So when I multiply these and add them, I'm going to get a new row that's going to give me my new row 2, giving me a 0 on the A spot. So the way that looks is negative 25 row 1, I'll do first. I'm going to multiply row 1 by negative 25. So that's going to give me negative 225A minus 75B minus 25c equals negative 275. Now I need 9 times row 2. So here's my negative 25 times row 1. Now I need 9 times row 2. So I'm going to have positive 225a plus 45b plus 9c equals 277. So that's 9 times row 2. I'm going to add those together, giving me 0a, which is what I want, negative 30b minus 16c equals, sorry, my 277 should be 279, so this gives me 4. And now that's my new row 2. So I've got a new system. 9a plus 3b plus c equals 11. I didn't change that. Row 2 is now negative 30b minus 16c equals 4, and row 3 is c equals 11. And so I've created a void here in the bottom left corner, which is attractive when you're trying to use elimination. Now we just have to back substitute. I start at my bottom equation. I know that c is 11. So I go to the prior equation and I plug in 11 for c. So I've got negative 30b minus 16 times 11 is 176 equals 4. And now I can solve this for b. Adding 176 over, I get 180. Dividing by negative 30, I get negative 6. So now I know my b value. Okay? Now I can plug in my c of 11 into my first equation, and I can plug in my negative 6b value into my first equation and solve for a. So I've got 9a plus 3 times b, which is negative 6, so that's negative 18, plus c, which is 11, equals 11. Moving all that around, I get 9a equals positive 18, so a equals 2. Now, remember, our goal is to get the function, the quadratic function that passed through the 3 points that we had to start with up here. Well, the quadratic function's form looks like this: f of x equals ax squared plus bx plus c. And now I have my a, b, and c values, so the function, the specific function in this problem is, well, a is 2, so I've got 2x squared. B is negative 6, so I've got minus 6x, and c is 11. So this is the function that passes through what was it, 0, 11, 3, 11, and 5, 31. So this is the quadratic function that passes through those 3 points. So it's a really interesting process. It's not as straightforward as the linear function example because you only need 2 points there, and it's linear, so you just need a slope basically. Since quadratic functions curve, it's a bit more complex, and you can see how systems can creep in here because of the fact that there are 3 unknowns in a quadratic function. So a system of 3 equations can be useful.